All right, guys, welcome to the third and final part of the review, second day, even problems. I am up to problem number 36, and we're going to finish the packet on this third part. So here's 36, which says determine the inverse. All right, so y is equal to log base 5 of x minus 3. And if you remember, an inverse from lesson 1 and from chapter 4, you switch x and y. So an inverse of a function, this is only for functions, inverse functions, I should write that. Inverse functions switch x and y. So I want the inverse of this guy. I'm going to switch. X is equal to log base 5 of y minus 3. All right, well, here's my base. Here's my base. And here's my exponent. X is the exponent because log means exponent. And here's my power. And I'm going to switch the exponent and the power. And so then this would give me y minus 3 now on this side from lesson 1. And x is the exponent. So then if I add 3 to both sides, here is the inverse, 5 to the x plus 3. Now, if you have a graphing calculator, put this in y1, put this in y2, and you're going to see here, this is your log graph, and then you're going to see here, this is your exponent. These guys would be inverses of one another. They'd be mirror images. All right, 38. Now we've got the domain, and again, we already saw the domain on the other problem in the second video. And on yesterday's work I sent you, log base 7, log base 7 of 3x minus 2. Again, for just the plain old y equals log base 7 of x, the domain has to be greater than the asymptote. X is greater than 0. There's your domain. So now, this guy, we added a whole bunch of fun into the parenthesis, but the domain, same deal. We have to make sure we're bigger than our asymptote. So 3x minus 2 is greater than 0. Add 2. 3x is greater than 2. Divide by 3. And your domain, x is greater than 2/3. So you just remember to take whatever in the parenthesis, have it greater than 0. If it's just an x, there's your domain, greater than 0 on a log. If there's other stuff in there, just solve it, and there you go. You can write it like this. Set notation, you can say for all values of x such that x has to be greater than 2/3. Or you can write it in interval notation, bracket, because we can't touch 2/3, but then we're going to positive infinity. Quite honestly, I don't care which way you write it. As long as you write it correctly, I'm good. So that was actually 38. I don't know why I wrote 36. So that was 38. All right, so now number 40, we are going to solve an equation. Log base 2, 5x plus 4 equals 6. Let's erase this. So number 40, solve log base 2 of 5x plus 4 equals 6. Okay, the base is 2. The base is going to stay 2. This is the exponent because 6 is the log. 6 is the exponent on 2, and this is the power from lesson 1, and we're flipping. So 2 to the 6th is equal to 5x plus 4. 2 to the 6th is 64. So we're going to subtract 4. See, once you do the hard part, the rest is like so nice. So 60 is equal to 5x and divide by 5. And you get 12. X equals 12. So once you do that little flip, life is pretty good. So now, problem 42. Find to the nearest hundredth the log base 5 of 220. Well, this one's nice and easy. 42. Log base 5 of 220. Okay, log of the power divided by log of the base. Log of 220 divided by the log of 5. Type this guy into your calculator and you get 3.351. 3.351. It goes on and on. I'm out of room, but they said to round to the hundredth. So if I'm looking at a 1, 3.35 equals x. Please always make sure you're rounding to the correct amount. Let's take a look at 44 now. Another one in which we need to solve. And this one gives you a natural log, so they say solve in terms of e, so you don't even have to type in and get a number answer like this. Let's take a look at 44. 44 says 2 natural log of x plus 5 minus 1 equals 7. All right. So again, if I have a whole lot going on, I think about PEMDAS in reverse. I'm starting here, working my way to the left, add, subtract. There's subtract, that means I'm going to add. You do this, you're going to always solve these correctly. Now, multiply, divide. I'm multiplying by 2, I'm going to divide. These cancel. So now I'm just going to come up here. I have natural log of x plus 5 is equal to 4. Now remember, natural log comes from the log base e, x plus 5 equals 4. The base is e. 4 is the exponent and the power, x plus 5. And they said solve for x. So if I subtract 5 from both sides, I get e to the 4th minus 5 is equal to x. And I didn't have to type this in. If they wanted me to find the numerical value of x, then of course I would have just put e to the 4th, come out of the exponent, minus 5, and given a number answer. So that one was pretty nice. Erasing this board and not having the whole tripod flip over is quite difficult every time. All right. There we go. Is that good? All right. Don't want it to completely fall over and lose everything. All right, so we are on 46, solve algebraically. Let's see if orange works. I'm going to move for a different color. 46. All right. You have 9 to the x squared minus 9x plus 14 is equal to 27 to the x minus 4. Well, here's my 9. Give me change. 3 squared. And the exponent doesn't leave. Here's 27. Give me change. 3 to the 3rd. And the x minus 4 doesn't leave. We're equal. Bases are equal. Exponents are equal. But don't forget to distribute. This is 2x squared minus 18x plus 28 is equal to, over here distribute, 3x minus 12. All right, quadratics equal 0. So I'm going to subtract 3x and add 12 to both sides. Minus 3x and add 12 to both sides. So now I have 2x squared minus 21x plus 40 equals 0. So I don't have a GCF of 2 because 21 is odd. So this is when I have to go back and I have to use that method from chapter 1. We haven't seen this in a while, but what a good review. Of factoring, I have to multiply 2 times 40 and I'm going to get 80. And then I need factors of 80 that add up to negative 21, which means they're both negative. So let's go through my factors of 80. I have 1 and I have 80. I have 2 and I have 40. This is when we did this, we would have gone back and done this. 3 doesn't divide in evenly, but 4 does. 4 and 20. 5 and 18. Does 6 divide in? No. Does 7? No. 8 and 10. 9 doesn't. And then I am back to 10. So when you do this, remember your factors make a nice little loop and they're in order. But now which one of these are going to add up to 21? None of them. None of them are going to add up to 21. So at this point, I would have to use the quadratic formula. I would have thought that they would have given us one that would have worked nicely. 5 and 18 add up to 23. I didn't add that wrong. That is 21. So yeah, this one you would have had to use quadratic formula. So you know what? I'm not giving you something this hard. Either they made a typo or something on this. They're telling me that there's a rational answer, but none of these work. So they have a mistake on the answer key. This one you can't do any further. So we're going to leave it at that. All right, let's go to 48. I don't like it when they make mistakes. I mean, I know I make mistakes. I'll fix my mistake, but I can't fix their mistake. If that middle term would have been a 23, we could have solved this, but it was a 21. Okay. Alrighty. Anyway, back to this one. 48. Town board planners are trying to model the population of Red Hook. They have found that on average Red Hook's population is growing. So my rate is growing at a steady rate of 4.5%. And year 208, so the time is going to be in years. 208 equals time 0. This is when they're starting. And that gave me an initial population of 5,000 people. And they want you to write an equation using P to find the population in 2033. So now I want the time to be 2033, so minus my 28. And that tells me 13, 5, and 25 years. So I want to know the population in 25 years. So the population is the initial population. I'm keeping the population. I'm growing by 4.5%, and I'm doing this for 25 years. So this one is a nice plug-in. And so this gives me the population when I type it in, 15,027.172. And even though we don't like to round to a piece of a person, if I just take these numbers and I do what they said to the nearest whole number, I get 15,027 people. would be the population. So that was number 48. Number 50, solving. And I have log base 2 of x squared minus 20 minus the log base 2 of x is equal to 3. Okay, so this was from our lesson 5 and maybe even lesson 6. We're solving. No, this was just on lesson 5. So this is on lesson 4 and lesson 5. Log laws. This was quotient. And so if I factor out the log base 2, I have x squared minus 20 divided by x, and this equals 3. So now if I use lesson 1, base of 2, 2 to the third is equal to x squared minus 20 over x. 2 to the third is 8, and 8 times x gives me x squared minus 20 equals 8x. So now I have x squared minus 8x minus 20 equals 0. Factors of 20 with the difference of 8. This would give me x minus 10 and x plus 2 equals 0. So x is either 10 or x is negative 2. Now you're definitely going to want to type these in and see if any of them are extraneous. And I do believe that this guy is extraneous. So you type this in, you're going to get an error message. So this guy we can't have. Here's my only answer. And 52, we want to determine where these two graphs meet. That means what we have to do is set them equal to each other. So number 52, I will be doing up here. And this is the final problem on the worksheet. Okay. 52, if you have in y1 log base 3 of x minus 6, you have a graphing calculator. I would do this on the graphing calculator. y2, you have 3 minus the log base 3 of x. You type this in, you hit intersect, you are going to get that they are intersecting at x equals 9 and y equals 1. You can do this so fast on your calculator, your head would spin. You don't have a graphing calculator, you have to do the algebra. Log base 3 of x minus 6 is equal to 3 minus log base 3 of x. Now what I'm going to do is I'm going to add log base 3 of x to both sides. And what I get is a long problem. I get log base 3 of x minus 6 plus log base 3 of x equals 3. This is the product rule. And this would give me log base 3 of x minus 6 times x equals 3. So now what I would have to do is I would have to multiply. So let's get rid of this. Come on. Let's try to keep my board from falling over. It doesn't want to cooperate right now. There we go. So now this would be log base 3 of x squared minus 6x equals 3. Or base of 3, 3 to the third equals x squared minus 6x. Well, 3 to the third is 27. Quadratics equals 0, so I got to bring the 27 over. And 0 equals x squared minus 6x minus 27. Factors of 27 with the difference of negative 6 would be x minus 9 and x plus 3. And this would give me x equals positive 9. This would give me x equals negative 3. You check them into the original, and this guy is going to be extraneous. Now, I'm not doing the check. You can do the check without me. You could type in log base and 3 minus 6. You could type in the log of negative 3 divided by log of 3. You'd get an error message right away. So this guy we got to get rid of. Here's 9. After you find that x is 9, then you would have to type in, so to complete the algebra, knowing that this is my x, I would have to type in the log of 9 minus 6, or the log of 3, divided by log of 3. This will give me 1 whole. And then the other side. Now the other side has 3 minus the log of 3, no, the log of 9, excuse me. The log of 9 divided by the log of 3. And then this would give me 3 minus 2 on the calculator, which is 1. Since both sides equaled 1 whole, it works. You know that you're going to equal 1. So therefore, when you had x and both sides gave you 1, there's your point. The algebra is a whole lot harder, so let's hope you guys have your graphing calculators handy. All right, so there's your whole review sheet. Your test is tomorrow. Ladies, gentlemen, please, please communicate with me on anything you don't understand. You can say, I don't know what you did on problem 28, and I'll write back to you. Please let me know when you don't understand. Please study. Good luck tomorrow on your test. Do not forget to go on tomorrow to take your test. All right, have a good day.